Hello everyone. So will be the second Q&A session for your lecture 2A on exceptions. Let me make some announcement first, as usual, just to remind you what are the coming milestones for the course so you don't miss them. And then I will go over your questions if you got any. Okay. Let's now talk about some announcement, which will be important. Okay. For your lab number 1, notice that it's going to be due tomorrow, October 1st, Friday, and it's going to be 2 p.m. Eastern time. Okay, just be reminded. The deadline will be strict. It's being set to close automatically, so it's not going to be allowed for any extension. Please make sure you allow enough time to make your submission. And then your written test number 1 is about to get started at 2 p.m. today. Okay, actually in about less than an hour. But of course, you got 24 hours window to actually do your attempt. You'll be given 20 minutes as specified on your guide. Okay, just notice that it's going to be between today and also tomorrow. And for those of you who might decide to maybe work on your lab number 1 until maybe tomorrow, notice that the submission for your written test 1 will also close at 2 p.m. Eastern time. Okay, so if you really decide to kind of do both on Friday, you just gotta notice that you really want to allow yourself to, for enough time to submit for both. Okay, that's something you have to watch out for yourself. And for your lecture week number 4 on JUnit tests and also exceptions, it's been released since Monday. So I hope you already got started, right? It's also going to help you on your lab number 2, which will be released soon. And something I also want to go over with you maybe quickly, if you have time at the end of today, I want to talk briefly about your programming test 1. It's going to happen a week from now. So I make available policy coverage in a guide PDF, pretty much like your written test number 1, right? The guide. And also I gave you some practice test, which will definitely give you some idea about what the test can be like. But the format will be very similar to your lab number 1. You will be given JUnit test cases, and then you are supposed to figure out the classes and methods and put it into the model package. You will be given 90 minutes, 90. Okay, but you gotta read the guide. It's really important since it's gonna be your first programming test. You're going to read the guide very, very carefully about the policy. Okay, and also the practice test. It's been released since yesterday. And for your lab number 2, I'm working on that. So hopefully I can release that by the end of tomorrow, Friday. That's the plan. Okay, so that's about the announcement. Let me just remind you very quickly before I take if you got any questions. Again, you should always remind yourself where you are in the semester calendar over here. Okay, so today is September 30th, right? You can see today is the start of the written test 1, and tomorrow make sure you submit lab 1 and also written test 1 in time, both. And then I'm going to release by the end of tomorrow, hopefully, lab 2. And then you will be given about 2 weeks to do that. Okay. And for your programming test number 1, it will be next week around this time. And then you definitely got more than 1 week to get prepared. So you want to start early for your preparation rather than the day before. Okay, so that's about the announcement I would like to remind you about. Are there any questions related to the administrative issues for the course? I'll take them now. Are there any? Everybody's okay? I'll pause for a moment in case you got any questions. Let me see. Okay, will I have office hours during reading week for lab 2? Yes, the answer is definitely yes. However, I may not have the same hours for the office hour. I may have to shift them a little bit. I haven't decided yet. But I definitely have office hour for you guys, to help you lab 2 for sure, because there will not be any scheduled labs for the TA. That's just the policy. So I think I'll definitely make myself available. I'll announce to the class about the hours, so don't worry. Okay, good. Would our programming test include new material that will be taught in week number 5? No. So I would suggest check the guide for the programming test. You know what? Why don't we do it now? Quickly, okay, in case you guys are having some doubts. So where can you find the guide for the programming test 1? So go to the lectures page and then go under week number 4 over here. Okay, you will see there's a guide over here. And for the practice test, you can simply just go to the e-class. Let me talk about it now, since you guys might be keen to know. Okay, that's the dates for programming test 1. Strictly individual, and then it will be 7% of your course grade. I think for the very first programming test, I'll make it slightly lighter, so just for you to get used to it. But for the subsequent 2 programming tests, you'll be slightly heavier. Just watch out. And you'll be a purely programming test, meaning that you're gonna import some Java projects like in your lab 1, and then after you're done, you have to export it as a zip, and then you're gonna submit it to E-class. So for your programming tests, you don't really submit through web submit. Just watch out. Okay. So when you actually do the practice test, you will see exactly what a workflow is like. Make sure you get yourself familiar. And the timing constraint will be somehow similar to the written test in the following sense. It's going to be open at 2 p.m. and close at 2 p.m. on the corresponding Thursday and Friday next week. And you will be given 90 minutes. However, I want to emphasize the 90 minutes, you should really allocate about 10 minutes or roughly 10 minutes to make sure you cover the time to really download the starter project and also import to Eclipse. And also when you're done, you also got to export it to zip and also upload it to eClass. You may even want to include some time for you to re-download the project and verify it. So you got to calculate those time as well. It's not the entire 90 minutes is for your developments. You got to be careful. Okay, so you can see once you click on the test link and choose to start it, a timer of 90 minutes, including all the things I talk about, right, will start. And the time limits is really strict because it's set by the E-class. As soon as the timer expires, E-class will disable the submission. Okay, so here is some policy here. I really hope that you wouldn't need to use it because that would be involve some penalty, but you just have to make sure you get yourself familiar with the workflow. Okay, so submission is going to be through the E-class, not web submit. And also, it is your responsibility to make sure you actually submit the right file that you want to be graded. Okay, some students from my earlier course, they simply submitted the starter code for grading. Of course, they wouldn't get anything, right? It's you definitely want to make sure you after you submit, you can download from E-class to make sure you download the right you submit the right file. Okay, what about email attachment? Let's say, for example, you were given 90 minutes, somehow you use up all the 90 minutes and realize you haven't submitted yet. And then what should you do? If that really happened, first of all, running out of time is not really a valid excuse to say, I need to send my instructor the email submission. However, if you can make sure you can send it to me within 5 minutes after your attempt time. For example, if you start at 2 p.m. sharp, your end time should be about exactly 3:30 for 90 minutes. If you can email to me within 5 minutes before 3:35 in this case, and then I will consider accepting the submission. Okay, but of course, you really want to avoid this. If you just want to make sure you really allocate yourself enough time to submit, then you don't need to. We don't need to get to this policy. Okay, and then if an email submission decided to be accepted, there will be a 15% penalty. Right? I really want to encourage you to really leave enough time to submit. Okay. There will be some programming requirements. One is about similar to Lab 1. You are not allowed to use any programming Java library like an array, like a linked list or array list or any like a system array copy. You can read it through. Similar. And also, if your project should really contain no compilation error. Okay, if there is any error, the TA will try to fix it for you if that's quick, but you will also receive some penalties, right? So you really want to make sure you avoid that. And the format is going to be identical to your lab number 1. So that's something you have been exercising already. And for the grading, you will be given some starter tests, but you will also be tested against other test cases once you submit your code, right? So if you really can manage, you should really try to write some test cases on your own as well. Okay, and here is simply just some tips about how you should really tackle the test. You can read it over, and then I will see if I can discuss maybe your practice tab maybe a little bit during the Q&A next week. But you got to do it first by yourself, so you will know what I would be talking about next week. Okay, some rationale about why we are enforcing the stringent time constraint, and also why we will take some penalty, for example, if your code doesn't compile. For the rationale, you can read it over, right? I really said very clearly over here. I'm hoping that it can be communicated clearly to you. Okay. And what about the coverage? It's going to be about OOP and mainly about your review tutorial series part 1 and part 2. Exceptions specifically will not be covered. So you do not have to worry about exceptions for this coming in programming test 1. It will be covered maybe in programming test 2, not this one. Okay. And so these are the two nodes you really have to make sure you get familiar with, right? That's something I have been emphasizing since day 1 of the course. And you don't need to worry about anything about GitHub, remote labs, or any terminal commands, right? Just make sure you don't need to be bothered by that. And some study tips. And you really want to familiarize yourself with the workflow of the test. Especially, you want to make sure you really are very smooth in exporting your project into zip somewhere to your computer and upload it to eClass. That's something you can definitely practice when you do the practice test. That's something I would need to assume before you take the test. Okay. And example test, you can download it. Let me just show to you. If you go to, let me go to eClass quickly. If you go to 2030, and then you will see under programming tests over here, right? You'll see there's a practice programming test. So you just go there, and then you can submit for the programming test one. You can attempt for as many times as you like, but for the actual programming test, only one attempt. And for the actual programming test, within your submission, within your timer, you can definitely submit for as many times as you like. For example, if you submit after 60 minutes, you decide to have a new version to be submitted, you can do that as well. You can submit multiple times within the deadline. That's okay. Okay, so that's about programming test 1. Okay. Do you have any questions regarding programming test 1? If anything, of course, you still got to read the PDF. I just did a very quick walkthrough with you. Any policy that's being set out in the PDF, you are responsible for obeying them. All right. Any questions? Go ahead, please.
Yeah. So the programming test, the practice programming test 1, once we submit it, is there a way to see like the answers for that or no?
Programming test 1, yes. I think I will try to release some kind of like an answer to you so you can compare. Yes, that's possible. But I think the way for you to know like how well you do is by seeing how many test cases you actually pass out of the total. You can get some idea. But I'll try to release maybe at least some partial solution sometime next week. I'll do that.
Okay, thank you.
Okay, good. Yeah, guys, but I will highly recommend don't really just wait for the solution, thinking that you can just go over the solution and get away from trying the test yourself. It's up to you, but I think it will be the best, most effective way for you to prepare if you tried it first. And then normally what I advise the student to do is as follows. If you're not so confident about your programming skill at the moment, you should really get yourself as ready as possible and then set yourself a timer, like a real test. And then try to do the practice test for the first time. And then try to see how much you can really achieve within the 90 minutes for the practice test. And then whatever you can achieve may not be very good, but still come to me during my office hour or set an appointment with me. I can take a look at what you have achieved within 90 minutes. So that'll be much easier for me to advise you how to improve. All right. Okay, any other questions related to programming test 1? Any administrative issues? Yes.
So kind of like the test is gonna go like you one step at a time. We'll try to like pass the test cases. So if you don't solve all of them, would you kind of get partial marks for the ones you do, or
yes.
How would it work?
Yeah, the answer is yes. So for example, it will be very similar to the way we're going to grade your lab. Very similar. Okay, maybe some mention somewhere. Let me mention that. For example, let's say you were given, let's say 5 starter tests. You can only pass maybe 3 of them. You will definitely get the partial marks for the 3 tests that you actually pass for sure. Yes.
But generally saying the bottom ones at the end, they tend to be more difficult. Just like looking from the lab. So would the weight of them the same?
Oh, the weight. That's true. That's true. So that's why I try to be very careful when I say it. You will definitely get partial marks for those test cases you actually pass, but the weights for the test might be a little bit different, as you said. Maybe some test cases are maybe mainly assessing the simple methods. They may have lighter weights. On the other hand, some other test cases, they might assess the methods with like a more difficulty. So that might have a heavier weights. That's something I'll leave the detail to the grading program. But the bottom line is, whatever, if you at least you pass some test cases, you should really aim for pass as many as possible. In that case, you'll definitely get partial marks.
Okay.
Okay.
I'll ask
Good.
a question after when you get to lab 1, maybe.
Oh, you got a question about lab 1? Yes, that's also possible. Yeah, I'll get to that. Yeah. So guys, if you got a question about lab 1, I think since it's more like a Q&A that's broadcast to everybody, I'll be more than happy to maybe take a question first, given that it's not so related to your particular implementation, which should be dealt with during my office hour or with the TA. But if it's more about general clarification, I'll be more than happy to do so today. But I'll get to lab 1 in a moment. Okay, any more questions related to any milestone, any administrative issues about the course? All right, hearing none. Okay, so for you guys, I think let me mention one more thing. Okay, so if you go back to under week number 3, you will see the recording from yesterday about the Q&A. If you click on that, you will actually see some stuff over here. For example, if you just show more, I got the timestamps over here. So these are the topics which I spoke about yesterday. And you can definitely refer to some of them if you're interested. Okay, I'll leave that to you. And I just checked the Google Doc about 5 minutes before our session. I didn't see any new questions. So now I'll open the floor to all of you. If you got any questions related to exceptions, tutorial, or any course material, it will be now time to ask. If you got questions about lab 1, please hold them. I'll deal with lab 1 after this part. Go ahead. Yes, please.
I don't know. It's about the practice written test.
The practice written test? Yes, that's possible. Yes, which one?
Okay.
Let me just go to E-class. Yeah, let me go to E-class first.
Yeah, for sure.
Yeah, practice test 1. And then let me preview. Okay. Which one is it?
Question 4.
You know what? Maybe tell me what it is about, because it may be randomized already. So.
Oh yeah. So it's the one that so it gives here. I'll just read it. So assume that a person class is already defined and it has an attribute name, a constructor that initializes the person's name from the input string.
Oh, is it this one here? I'm showing here.
No.
Okay, could be the other one. Okay, I might know which one you're talking about. Give me a moment.
The one with the for loop.
Yep, of course. Possibly here was 7. This one here?
Yeah.
Okay,
yeah.
Sure. Why don't we talk about it? Yeah, absolutely.
I'm more confused. I kind of got like more confused about just the how the for loop ended up going.
Okay, sure.
Like the I-1. That was
no problem. Why don't we try that together? Yeah, let's try that together. Absolutely. Okay. Let me set it up. Just bear with me for 1 moment. Okay. Okay, good. Okay, let's solve it together. Let's read the question again. Assume a person class that's already defined got an attribute name, a constructor that initializes the person's name from the input string, an accessor get name returning the person's name. Now we consider this fragment over here. Okay, so I think if you got a question like this in the written test or maybe later in the exam, so always got a piece of sketch paper ready, so you can actually just visualize right away, so you can save time. Let's try this. So we got this part here, we got 4 person objects. Let me just do that right away. So we got P0, P1. So we got P0 pointing to a person objects. Okay, person over here. And it has a name attributes. Okay, let me just copy this structure over here, and we need 4 of them. Let me visualize all 4 at the same time. Okay. P0, P1, P2. Okay, maybe make some space, and P3. Okay, so P0, P1, P2, and P3. P1, P2, P3, and the first one is Suyang, and the second one Yuna over here, and then Sang Hei, and also Ji Hei. Okay, I'm pretty sure these 4 lines you have no problem. Let's now talk about the next 2 lines over here. So we got P0 is assigned to P2, and also P1 is assigned to P3, right? That's also something we review during part 2 of the tutorial. So basically what it is doing is, after this assignment here for the first one, P0 is now going to point to wherever P2 is pointing to, right? It's going to copy the address. So P0 is going to point to wherever P2 is pointing to, like this. And then the next one, P1 is going to point to wherever P3 is pointing to. P1 is going to point to wherever P3 is pointing to. Okay, so far, are you okay so far?
Yeah.
So far it's okay. Okay, let's continue. Just want to make sure. And then let's now do the next one over here. So what about this person's one array, right? Let's first of all create the array. You can see this notation over here is creating an array of size 4. 1, 2, 3, 4. More specifically, it's going to be indices 0, 1, 2, and 3. Okay, let's now do it. So you got person's array is going to store the starting address of the array of size 4. Okay, let's put it 1, 2, 3, 0, 1, 2, 3. Okay, and now we're gonna be careful when we assign that. And index 0 is going to store wherever it's going to point to wherever P0 is pointing to, right? P0 currently is pointing to this object over here. So that's why person 0 should really point to here. Okay, P1 is currently actually being redirected to over here. So that's why person's 1 should point to here. And also P2 is still pointing to this object over here. So P2 over here. And also P3 is actually pointing to this object over here. So that's what we have. Are you okay so far for this first array?
Yeah.
Okay, very good. And the tricky bit is going to be the next one, but we're going to handle that systematically. So what's going to happen in the next one is, let's see here, we got persons 2 array. The length is going to be persons 1 array. The length is also going to be of size 4. Let's do that first. So what I would do is I'm going to put, let's say, persons 2 array is going to point to an array of size 4. 1, 2, 3, 4, 0, 1, 2, 3. Okay. And then to really understand this particular for loop, you got to think about a little bit higher level to think about how many iterations, first of all, and how the loop counter is going to change during the loop. Let's look at this part specifically. Okay. Can you tell me how many iterations are we going to get in total?
3.
3?
Yeah.
Are you sure? Okay, initialize to be 0. And persons 2 dot length.
Oh yeah,
is
no, 4.
4, right? Okay, be careful, right? I'm just trying to help you understand this, right? It will be 4. So that means the I, you can think about I value is going to be 0, 1, 2, and 3. So these are the 4 iterations. Okay. And then what we have over here is like this. Well, actually, once you figure this out, I think it will be quite obvious, but I'll do that completely with you. Persons to the length is going to be 4, right? So think about for the very first iteration. For the first iteration, it's going to be something like this. So persons 2 at index 0, right? It's when I is equal to 0. Is assigned to persons 1 at index 4 is always there. 4 minus 0 minus 1 is going to be 3. Okay, that's the first iteration. What about second iteration? For the second iteration, we still got persons 2 And then it's going to be 1, right? For the second iteration, 1, corresponding to here. And then this one is going to be 4 minus 1 minus 1, which will be 2. Persons 1, and then 2. All right, let me just use another color here. What about purple? Okay, for the third iteration, I will be 3. So that means it's going to be persons 2, and then 2. Right? The third iteration is going to be 2 over here. And then it's going to be 4 minus 2 minus 1, which is going to be 1. Okay, you kind of see the pattern already, but let's, for completeness, let's do all of them. What about the fourth iteration? I will be 3 over here. So it's going to be persons 2 at 3. And then persons 1 at, so 4 minus 3 minus 1, 0. Okay, are you okay so far?
Yeah.
Okay, very good. Let's now complete this. Okay, and now you just gotta be careful when you draw that. Let's do the first iteration. Persons 2, 0 is going to point to wherever persons 1, 3. Persons 1, okay, by the way, so this should be 1 here, right? Persons 1, 3. Right? You can see it is pointing to this particular array. So that means 0 over here is actually going to point to over here. Okay? And then let's do the second one. This one here. Persons 2, 1 is going to point to wherever persons 1, 2. Persons 1, 2 over here is pointing to here. So that means this one here is going to point to over here. Okay? And then let's see the third one over here. Persons 2, 2 is going to point to wherever persons 1, 1. Persons 1, 1 is over here. That one is pointing to also this object over here. So that one there is actually going to point to this object over here. Okay? And then finally, yeah, I'm kind of stuck in kind of running out of space over here, but hopefully on your sketch paper you can just spread out the objects a little bit. So here, finally, persons 2, 3 is now going to point to persons 1, 0. Persons 1, 0 is going to point to this object here. So that one there is going to be something like this. Okay, so that's kind of the pointer, right? And one thing to note, for example, let's say for this particular object, you can see how many incoming arrows do we have. You can see you got 1, 2, 3, 4, and 5. So another possible question I can ask will be how many aliases do we have for this particular object? The answer is 5. 1, 2, 3. Oh, actually, 1, 2, 3, 4, 5, 6. There should be 6, right? It's an additional question. Okay. Let's now talk about the addresses. Okay. Actually, not addresses, about get name. Okay, let's now do one by one. The first one, persons 2, 3 dot get name. Okay, persons 2.
I mean, I think I know how to do it.
Okay, are you okay?
But
should I maybe stop here so you will know how to continue, right?
yeah, I do know how to continue. Yeah, I
Okay.
was more confused about the
Awesome. Okay,
yeah.
but I think maybe this part will help you. This part, I think
Yeah,
that's how you
yeah.
understand the stuff. Okay, no problem. Okay.
Thank you. That was clear.
No problem. So guys, I hope it will be okay if for me not to continue, right? So hopefully you guys will know how to figure out the rest. Okay, good. I see John. John, do you have a question?
Yep, it was related to the other person question.
You got other questions? Okay, go ahead. Yes.
It was the other person question. I just wanted to know like the difference between two calls. Do you mind sharing the quiz again? What was the other person question for the
The other person question. Okay.
Yep.
Let me go there. Yeah, sure. Of course. The other one here. Let's see. Yeah, was it 2? Yeah, this one here?
Yeah.
Okay.
Yeah, just the difference between P0 equals P1 and then P0 equals persons at 1.
Okay,
they refer
sure.
to the same.
Okay, they're kind of the same. How about okay? Since your question is specific, let me answer specifically. Let me also set this up so your fellow student can also benefit. Okay, let's see over here. So John, your question is really about the difference between this line over here and also this line over here. Is that correct?
Yeah, and the same thing for 6 and 9.
Okay, 6 and 8. 6 and 9?
The difference between
6 and 9?
Yeah.
Okay.
Yeah, the difference between 6 and 9 and the difference between 5 and 8.
Okay, 6 and 9 and also 5 and 8. Okay, I see.
Yeah.
6, let me just be more careful when I draw. Okay. 6 and 9 and also 5 and 8. Okay. As usual, let's this one may be easier to draw. Okay, why don't I just draw quickly? Okay, maybe without worrying about the actual value for the string. So we got here, we got P0. So we got P0 over here is going to be a person objects. Okay, you can put the name yourself. And also we got P1, also some person objects. P2, also some person objects. P3, also some person objects. Okay. And okay, so when we do P0 is assigned to P1. Let me use a pink, just be consistent. Line number 5. P0 is assigned to P1. That means P0 is going to copy the address from P1. Meaning that diagrammatically, P0, rather than pointing to this here, is going to point to wherever P1 is pointing to. Okay, so far?
Yeah.
Good. How about line number 6? P2 is assigned to P3. That means P2 is going to point to wherever P3 is pointing to, because you're copying over the address that is stored in P3 into P2. Okay. And then let's now just talk about this line over here. What about this array? That's something we just did in the earlier question. So this is so-called the initializer expression for the array, which we didn't quite do in the review tutorial, but something I would assume you will know. This is initializer. We got index 0, 1, 2, 3. Okay, so let's now do persons over here, an array of size 4. 1, 2, 3, 4, 0, 1, 2, 3. Okay, and basically the first element is going to point to wherever P0 is pointing to, right? So P0 currently is pointing to here, so 0 should be here. P1 is pointing to also this object here, so 1 is also going to point to here. P2 has been redirected to here, so 2 should go to here, and P3 is actually also pointing to here, right? Okay, and let's now go to the pink one again. When we say P0 is assigned to persons 1, that means whatever address that is stored in persons 1 at index 1, persons at index 1, whatever address that is stored there, we're going to store that into P0, meaning that P0, rather than pointing to over here, is going to point to wherever persons at index 1 is pointing to. Persons at index 1 is pointing to this object over here, right? Just happen to be the same. So in that way, P0 is still going to point to wherever persons at index 1 is pointing to. So there's no effects you can think about. Are you okay?
Now, so it's still, yeah, it still refers to P1, but now through the first object in.
Yeah, it's still the P1 object. Yeah, so you can think about, even if you do the assignments, they will still store the same address. Happen to be the same.
Okay.
So diagrammatically, you don't need to change anything. Maybe that's why you're a little bit confused. So whenever you do any variable assignments, it's not necessarily the case that you will store a different address. Sometimes you might just happen to store the same address. That's also possible, right? Okay, if we go on to the next one. If I say persons 2 is now going to point to wherever P3 is pointing to. P3 is pointing to this object here, right? And we're going to say persons 2, persons at index 2 is going to point to wherever this is pointing to. Oh, again, happen to be the same, so no change. So this will be,
I just know.
yeah, so this will be the final outcome.
So
Does that answer your question?
It still calls it. Yeah, okay. It still calls it, but the chain, nothing actually changes,
Yes.
but it still
Yeah.
does the
You think
call.
let me give you some analogy. Yeah. If you still don't feel very comfortable, thinking this way. If I say integer I is assigned to 23, let's say integer j also happen to be 23. So now if I say I is reassigned to j, right? So conceptually, you can think about you're really copying whatever that's stored in j into I, but they happen to be the same. So conceptually, there's really no change.
Okay, I understand. Thank you.
Okay. Okay, good. Okay, awesome. I see two hands over here. Forgive me, I don't know which one actually came first. If you don't mind, I'll just see which one's on top of my Zoom. How about Mohammed first?
Yes. Hello, Professor.
Hi.
I wanted to just I had a brief question. I got that question from the very first question that we went through right now.
Okay. You mean this one here?
Yeah, and you just briefly for like 5 seconds you talked about aliasing.
Yeah.
Can you elaborate more about that?
Of course. Of course. What I meant was, let's take this object for example. Okay, sure, I can definitely elaborate. Let's say for this particular object over here. So potentially there could be one question I can ask. Okay, let's say here, let me just say here. Okay. Okay, so here the question is how many aliases, how many names basically, how many paths, how many aliases are for this object? So that is the question. And when I said before, there should be 1, 2, 3, 4, 5, and 6. Okay, I'll do 3 of them. The remaining 3 I'll leave as exercise for you. Okay, so which 6? So they should be so the answer should be here. Okay, should be 6 aliases. Okay, let's see, this one is easy. Let's say this is the first one, right? The incoming arrow. So that should be persons 1 at index 2. Okay, let me go counterclockwise. Okay, how about this one here? This one as well. So this will be persons 1 at index 0. Okay, the third one could be here, right? So this will be P0. Okay, and then for your exercise, can you try to fill out? Maybe after the session, you can do it by yourself. Number 4, number 5, and number 6.
Yeah,
So does that answer your
I can do it
question,
right
maybe?
now. Yeah.
How are you doing that now? Okay, very good.
Yeah, I can do it right now if you want me to.
Why don't you do it now, and then we can complete it together.
So the fourth one is going to be persons 1, index 1, persons 1, index 3, and then the last one would be
P2.
P2, yeah.
Okay, awesome. Yeah, let me write it down. Yeah, for the benefits of others. So it'd be P2.
Yeah.
Yeah, P2 is here, and then this guy here, go all the way to here. Okay, right? It's a persons 2 at index 1, and number 6 would be this guy here. The red is index 3.
Okay. I also wanted to know,
yeah,
what's the purpose of having so many aliases? Like, how?
Okay. You can think about. Okay, so the reason that we want to have aliasing is because you don't really want to have duplicates the same objects for so many times. You can think about if we do not allow any aliasing, then in that case, every one of them, rather than storing the same address of the same objects, we will have to duplicate this particular object six different times. In that case, for this object, it's okay. It's a simple object with only a string value. But in general, object structure can get very, very complicated. So like a sketch. Okay. So in general, your object structure can look like, for example, maybe this is a pointer to that particular object. That one may have maybe 2 attributes over here. And then each one of them might just refer to just another object over here. And then, so here just another pointer and etc. So in general, the object structure can be recursively complicated. In that case, we will definitely want to have aliasing. Aliasing, just for you, rather than creating the object for so many times, you can simply share its addresses from different paths.
Okay.
Also, you also make real sense. I can tell you why. Let's say, for example, let's say we have let's say 2 children. Let's say we got, let's say persons, let's say child number 1 and child number 2, right? Child number 1 and also child number 2. Let's say both of them are person. And let's say the name over here and the name over here. Let's say one is Suyang over here and the other one is Yuna, for example, 2 children over here. Let's say we have an attribute over here called maybe father over here and also father. If they're siblings, it wouldn't make sense for them to have 2 different objects being their father. Well, it's possible, but I'm just saying in some cases it may not be the case, right? So correct. It's better that their father would simply point to the same person objects. So that will also fit the modeling purpose of the real scenario, real life scenario. So I think for aliasing, back to your original question, number 1, you can save space. You don't really have to duplicate the memory, the objects. Number 2, I think in real life, you actually got sharing of the object very often, the concept. So that's why aliasing will be useful.
Yeah, that answers my question.
Okay,
thank you.
Awesome, no problem. Okay, so the next one, how about MV? I'm not sure how to pronounce your first name. Yeah, go ahead, please.
Hi. So I was just going through the practice written test,
and
I'm comfortable with the other questions except the one with the
Which one?
call stack. So I was wondering if you could just
of course,
go over how we can solve.
Apparently, my practice written test runs out of time. Okay, let me start a new preview. Okay, let's do it again. The one about call stack, right? Okay, let's see.
Yes.
Let's take a look. Give me a moment. Number 3, number 4, number 5. Not this one, is it?
No, it's the
Not
one
this
with
one. Okay,
the
meaning with the diagram. Okay, I see. Yeah, let's take a look. This one here.
Yes.
Okay, good, awesome. Okay, let's read it together. Consider the following. You know what? Again, let me set it up on my iPad so that'll be easier. And then I can even talk about other diagrams, which is available for your week 3 lecture. Let's now go there. Okay, so put it here. Okay, let's talk about this diagram specifically first. So let's see. Okay, consider this call stack. First of all, you really want to understand the arrow, right? You can see this part here is a caller makes a call to its callee. This becomes another caller makes a method call to its callee, right? So that's a caller callee relationship. And this part over here is about how the exception is propagated. In this particular example, we are saying that a.ma is where we throw the negative value exception. And typically for the class where the exception is originated, we don't really use the catch option. We don't want to catch it right away. We at least want to propagate it for one level further and let the later caller to handle that. Okay, so that's what we do. So we propagate it to one level over here, and then it just happened that for this particular caller, they choose not to handle. Remember, the catch will specify options. So you got the option as a caller to either catch or to specify. And in this particular caller, they choose to specify. So that's why the exception gets propagated one level further. And then for this tester, the main caller, again, they got 2 options, either to catch or specify. And in this case, they actually choose to handle, which means they want to catch it. So that's why it's handle already here. Otherwise, it would have been propagated even further to the console. Okay, are you okay so far about the explanation?
Yes, so I'm guessing that the
Mhm.
From the first stage to the second stage, when they throw the exception, the second stage does not wish to handle it. That's gonna be
Yes, exactly. So you can think about it from this for this guy here, it's specify, and for this b.mb, they also choose to specify. So that's why it's propagated further. And then for this caller here, they choose to catch it. Okay. So
right.
now
So then that's what. Okay.
exactly how many specify? So it should be 2, 1 and 2.
So it should be okay. Yeah.
Yeah. Okay. Good. On the other hand, let's do a little bit more practice for you, shall we? Let's now go back to your lecture site. I think that one should be version number 2, I believe. Okay, how about this? It's for you. How many callers choose to specify in this case?
Okay, so in this case, we're throwing the exception again, so that would be 1 specify to the
Good.
second
And
method,
then?
but then this time they're handling the error.
So that's the catch.
Right. So we shouldn't move any further. So it should just be 1 specify.
Awesome, awesome. For what's worth for other people listening to this. So for this guy here, you might be wondering, should this be considered specify or catch? It should be considered as neither, because as soon as the exception has been handled, you don't have to propagate it any further for the caller to worry about. So that's why this is neither specify nor catch. Okay, so this one just 1. Awesome. Let's do one more. How about this one here? How many specify?
Okay, so we have our first specify from the throwing exception. The second block does not handle it, so it gets further specified. Or we have 1 more specify.
Yeah.
And then it still does not choose to handle it, so it gets promoted to the next stack. So it should be
next level, which in this case a console. So we got how many?
There should be 3 specify.
Awesome, brilliant. Yes. Yeah. Hopefully now you can get a much better idea about the propagation. Yeah. So guys, I think not just for the written test, but I'm not sure if the written test will really test you exactly about this. But I think just make a note to yourself, so later on when you prepare for the exam, you can also you will know that's something you should really review. So either I might give you a diagram like this, that's possible, or I can simply give you maybe the fragment of code for A, B, and C, which might be slightly more challenging, but it wouldn't be so bad. You just have to know how to figure out the caller-callee relationship. Okay, so if I give you a fragment of source code for A, B, and C, and then I might just ask you the same question. At the runtime stack, how many callers actually specify it? Of course, if I give you the source code, you can easily just go into the source code and see how many of them actually say throws that particular exception as part of their header. That's another way to check it, right? You can make a notes. All right, good. Okay. Okay. I see John is still raising his hand, but John, let me get back to you a little bit later. I got some other student here, but I'll definitely get to you. Oh, actually, different John, I guess. This is the same John. We got 2 different John. Okay, maybe not this one. Okay, Abdallah, please.
I think John was here first. Like he had his hand up first.
Oh yeah, it's okay. I just don't worry about too much about order. I'll definitely get to all of you. So I'll just go with the order I can see from the Zoom. Okay. So Abdallah, go ahead.
Yeah. I just wanted more like elaboration on the codes for the exceptions.
More elaboration on again.
So just like how you said there could be questions where we have to look at the exceptions through like code instead of like blocks like that.
Okay, yeah. You just want more clarity on that. Okay.
Yeah. Do you have any like examples?
Yeah, sure. Of course. I can give you one example right away. Maybe using the example you're familiar with. Let me go to your lectures and then I will be precise over here. Okay. Yeah, bear with me. It's now relaunching. Good. Let's say if we go back to your week number 3 lecture example to handle or not to handle over here, and then let's say we go to version number 2, right? I might simply give to you the fragment of code for A, B, and tester, and possibly negative exception as well. let's look at A, B, and also tester, right? So now the question could be, how many in the runtime call stack, how many callers will choose to specify the exception, right? One way to do it is based on the code. You can actually formulate the diagram into something like this. That's one way to go. Another way to go is even easier, is by looking at, for example, A here. You can see for this MA, it's one of the callees. You can see as part of its header, it says throws negative value exception. So that means it specifies the exception. So that's one. If you go to B, you can see for method NB, he also says throws negative value exception as part of its header. So that's number 2, which says specify it. And if you go to tester over here, you can see the main method here as part of its header. It didn't say anything like a throws negative value exception. Instead, you actually got try and catch. So that's why it's not really specifying. Instead, it's catching it. So we only got 2 callers specifying the exception. That's really what I meant.
Yeah, but you also said that we may not get the source code, like where we would just see the throws.
Yeah, in which case you will just get a diagram like this.
Oh, okay.
Either you get this, in which case you just look at the diagram to see how the well, for example, how the exception got propagated, see the arrow, or you're given this, in which case you can either look into the throws, there's no throw, for example, here, and also, or you can simply formulate the diagram yourself into this, and then you can answer the question.
I got you. Okay, thank you.
Okay, awesome. Okay, so now next one, how about Amir?
Hi, Professor.
Hi.
I just had a quick question about lab 1. So I was just
Amir, so if you can hold it, I'll be happy to answer you, but let me handle all the questions related to exceptions, written tests, and then I'll get to lab 1 for sure. Yeah, just bear with me. Okay, good. Okay, I got 2 Johns over here. How about John Mai? You go first.
Hello?
Hello, yes.
Hi, I had a quick question. I had like 2 quick questions for 2 questions on the written test.
Okay.
The first one being, it was a question that said, from the following independent lines of code, choose those which compile without any syntax or type error.
Okay.
And the only thing I didn't really understand was how p.getDistance from origin. Sorry.
Yeah, I'm gonna get to that. I know exactly what you're asking. Let me just get to there. I got about 10 seconds left for my practice test. This one here, right? Okay.
Right, yeah. The only issue I didn't understand was how p.getDistance from origin was
this one here, right?
correct answer.
Okay, right. Okay, awesome. This one here. You have question about this one, I guess, right?
Right, yeah.
Okay.
It's a method that returns a value. So I mean, it's not used properly if it's alone, right?
Very good. I'm glad that you have that concept. You're right. P.getDistance from origin is an accessor method. It calculates something, it returns something, but it's not being used. However, remember the question here. I said which compile. Funny enough, Java compiler wouldn't treat this useless method call here as not compiling. So that will actually compile.
Okay.
I believe if you can go back to the review slides on classes and objects, I believe there's a single slide actually talking about this, which I said it's useless, but it will still compile.
Okay, that makes a lot of sense. So
yeah, but of course, for your information, you don't really want to write anything like this. That means there's some problem with the code. But unfortunately, Java wouldn't consider this as an error.
Okay. So it's only a compile error if it is either the type is wrong. So either I'm going from double to integer.
Exactly.
And it can't be implicitly demoted unless casted, or makes a lot of sense.
Yeah, good. Yeah.
And the second question was, it says at runtime call stack, a method implements a try catch block to handle the negative value exception.
Let's take a look. I might know which one.
It's like true or false, I'm pretty sure.
Okay. Let me go there. This one here, right?
Right.
Okay.
So Yeah, I'm not sure if I was reading the question wrong, but the way I understood it was there was one method and it was calling a callee and that threw an exception. Was the question asking if that method was then called by another third method, if that had to handle it?
No, only two methods here. Okay, let's try to read it together. Okay, at the runtime call stat, that one's okay. If a method implements a try and catch block to handle a negative value exception that may be thrown from its callee. So what it's saying is, let me give you that example there. Let's say here, not this, maybe I need to go for version number 1. Maybe this guy here. Let's say this method here is a caller, and this method here is a callee. The callee actually throws and possibly might throw a negative value exception. And when it is actually thrown, it's being caught by the caller. So so far, only two methods, right? And then if we go back to the question over here, then this method's caller, so yeah, in this case, we are referring to the third method. This method's caller, right? So now this method, which is b.mb, its caller, which will be tested and main. In this case, are they still obliged to actually do catch or specify? The answer is no, apparently, because the exception has been handled already.
Okay. Thank you. I appreciate that.
So I think, sure, no problem. I think for this kind of question, right? So I think in principle, let me just go back. I'll give you some general remark. In principle, when I ask about any question, I might either try to phrase it in a way I believe that's clear, or I might just give you source code. They got pros and cons, of course. If you got source code, it might be easier for you to actually see right away what it is. But on the other hand, it might be harder to trace. On the other hand, for the English version, you just have to kind of somehow visualize what's really happening there. So this might be something you want to pay attention to as well.
Got it.
Okay, do you have another one?
No, not so far. That's pretty much it.
Awesome. Okay. All right. What about the other John? Go ahead.
Yeah, I had a question about program flow with exceptions. Could we go to the iPad notes for
Sure.
Week 3's lectures?
Of course. If you can, first of all, you can tell me which node it is, then I will try to set up a new one. Are you speaking about this one?
It was the program. No. The one was with no exceptions. It was just with the color stack. It's earlier in the slides.
Earlier, okay. This one?
So, no.
Did you have a page number?
Yeah, sorry, here, I'll give it to you.
Okay. So guys, by the way, if you need to leave earlier, please feel free. Okay? Yeah, if you need to leave.
Slide.
Sorry, which number?
4.
4, okay. This one.
And I was curious, if there was exceptions in this one, how would then we go about the lines below it?
That's a very good question, John. I think at the time I introduced about this particular question over here, I haven't talked about any idea about normal versus abnormal execution flow. Here, it's only about call chain using method call, right? You were asking what if we got exceptions. I can give you some example here. Okay, it depends, right? So, let's see this. Let me just use two classes, just two methods, just to give you some idea. Okay, I'll make this up on the fly. One line here, and then let's say we got some method call. I'll just say object dot n1. Okay, assuming that all object O has been declared already. And then you got one line here, and one line over here. Okay. And then you got some catch. Okay, let's say we put the right type of exception over here, and then you got one line over here. Can I make this a bit larger? Okay, one line over here. Okay, good enough. And then let's say we are not in the context of one method. Let's say just call it n. Okay, let's say we talk about n1. So if I put n1 over here, and then the definition for n1, we can still actually gotta try and catch. And then we can say object2 dot maybe m2. Okay, and then and etc. Okay. This may not be a complete picture, but you'll get an idea. Of course, here we got actually different possible execution path at the runtime, because now we got two possibilities. Either M1 throws the exception or not, right? Either there are two possibilities. And also M2 may or may not throw the exception. We also got two possibilities. Okay? The combinatorial result tells us there should be four possibilities, right? But I'm just gonna mention some of them just to give you some idea. Okay, let's make the following assumption. Let's say M1 somehow throws the exception. Okay, and M2 does not throw. Okay, so now that's the first possibility, right? In this case, let's say it's going to be green. So let me use a green. What's going to happen is we're going to say try, and then the first line, and this one here. But since it actually throws the exception, right? So it could be from any line over here. It could be that we get to here, and then somehow you throw the exception from there, and from M1, and then it's going to be interrupted right away. So you will simply return right away. It could be that this might just be the throw exception, could be, okay? And then after this is going to be interrupted, and then it's going to go to the catch, and then it will finish the rest. Are you okay so far?
Yep. So any
Okay.
lines after.
Yeah. You know, my main point is, in case you got exception actually in the play, you have to worry about whether or not the exception has occurred. If the exception has occurred, in that case, the execution flow will be disrupted. It will simply just go to the catch block, bypassing the rest. In case the exception does not occur, you can still finish the method call over here, and then come back, and then go through the rest over here.
Yep. But anything after the second try.
Yeah. So John, I would say, you know what? I think I might need this example in some ways not very good. How about this? I'll keep a note of this question. I'll try to address this next Wednesday again. Do you think that might work?
Yeah. Okay.
Okay. Let me make a note. Okay. I'll try to prepare a better example. You know, I don't want to give you something that will make you more confused. Okay. So I would say a new example next Wednesday. Yeah, just come next Wednesday again, and then we'll talk about this example. I'll make it more elaborate, more precise. Execution flow of exceptions. Okay, I'll make a note so I will remember. Okay. Okay, John, any more questions apart from this?
Thank you. No.
Okay, good. Okay, awesome. Okay, next one, Daniel.
Hi.
Hi.
So I was wondering, so lab one.
Lab one. Okay. So yeah, just bear with me. I remember Amir and also you. Okay, give me one moment.
Sure.
Guys, do you guys have any more questions related to written test or maybe other lecture material before I get to Daniel and Amir about the lab? Anyone? We still got time, so don't be shy. If you still got things you want me to clarify for the lecture or tutorial contents, it's still your time. Okay. Hearing none. Okay, so I'll get to Daniel maybe second. How about Amir, since you asked first? Amir, go ahead. Lab one.
Hi, Professor. So
Hi.
thank you for time. I was just wondering, like during lab one, when I came to an obstacle. I don't know where I could find floating variables on the slide so that I could like.
Floating variable. You mean like a double floating variable?
Yeah, like on the thing, it just said that like what do you call it? Like it had something to do with like a floating variable. I'm not exactly sure from the top of my head what exactly in asking me, but I was just wondering where I could find like more information on like floating.
Okay, so I didn't really put it in the slides for the class and objects review, but I'll show to you. If you want to review some basics, if you want to, I'll show you where you can go. You can try to go to my 1022 in the winter, and then I would say you can see the maybe around week 1 or week 2 over here. I think especially week 1. If you go to things like a coercion, casting, and also I think around here you will find some information. But just go to the slides, elementary programming. You will see some information about floating number.
Okay. Perfect. All right. Thank you so
Meanwhile,
much.
you can let me know. Can you tell me which part of lab 1 you might be struggling with using floating? I might just be able to give you some hints.
I'm not sure exactly where it was because I closed the app right now. But
Okay. I'm just guessing. If you are wondering about how you can calculate, for example, average number, right? In that way, you may want to review something about coercion and casting. That might help you a bit about calculating with precision. That's one. Number two, if you're wondering about how you can format, like a floating point number with only 1 digit after decimal point, for example. In that way, you may for that one you don't need to look at the slides. You can simply review what we did in part 1 of your review series. We spoke about it over there.
Okay. Perfect. Okay, then. Thank you so much, Professor.
No problem. Okay. And okay, that's Amir. How about Daniel, please?
Yes.
Yes, go ahead.
So, yeah. So for lab 1, you gave us like a correction for the starter project. Like you wanted us to re-download it, right?
Yes, please. Yeah, correct. That's correct.
So I was wondering like how important that is because I didn't.
Oh, okay. I can tell you that the exact change I made. I only made one change. That change was simply to adjust the default setup for the compiler. Originally, I put 1.16 to match my machine, but I noticed that it might not work for some of your fellow students, maybe many. So that's why I kind of try to recreate the project using 1.8 from the remote lab, and that one might be the kind of minimum, the minimum standard everybody can at least satisfy. In your case, if you are still using the original one, 1.16, and without any trouble, I think it should be okay for you to submit a project. You shouldn't get into any trouble, given that everything compile and every test runs. However, if you really want to be 100% safe, I have about 2 or 3 minute solution for you. You can give a try. What you can do is you can simply re-download the empty model, the empty starter project from eClass, the latest one with 1.8, and then all you got to do is you can just copy and paste the 3 or 4 classes from the model package in there, and make sure everything works. You can submit that version instead.
All right. Thanks.
Okay. Good.
Yeah.
Anything
So
else?
One more.
Okay, go ahead.
So you encourage us to do like other test cases. So is that like making a new method or making a new?
Good. Yeah, you can. Yeah, I think I would suggest you don't really touch the 13 test methods I gave to you, because somehow that can give you some it can mislead you a little bit, because those will be run as verbatim when we as part of the grading process when we grade your lab. So keep those 13 untouched. But if you want to create additional one, yes, you just create some additional test methods. That's how you do it.
So we would create a new file.
I would say either a new file you can, if you want to, or you can simply extend by adding more methods to the same class. Either way is okay.
Okay, I see.
Okay, anything else for you?
No, that's it. Thank you.
Okay, good. Anton, please.
So I don't know if you can answer this question for me, but I'm trying to go through the lab 1 right now. I've passed like a first test, and I'm kind of stuck for the log 2 and app 1.
Okay.
And I have a feeling it's because I've completed, even though I passed my log 1 test, I've done the get fixes method probably like in the correct way. It basically asks for the empty set, right? Like array.
Empty array. Give me one moment. I think I can take a look. We may not discuss your code, but let me see. Let me just download the project again, and then we'll talk about it. If that becomes too specific, I might just need to ask you to drop by my office hour and we can talk about it further.
Okay.
Either way. Okay, give me one moment. Okay, that's what you were given for lab 1. You said it's the test log 2?
Well, log 2, I'm currently kind of stuck at the assert equals at the bottom where you have 2 strings.
Over here? Over here, okay. Okay, I can give you some general hints over here just for everybody. So I think you want to make sure when you say here, let me see this. Okay, over here. So this is where you create a new log over here. And then when you say app updates over here. So this one, give me one moment. Let me just make sure. Yeah, to fix this to the log. Okay, got it. Okay. So this one actually, okay, I was overthinking myself. Okay, let me go over that with you. So you can see there's a log with a version number, and then you can think about every time when you add a string fix into the log, you're going to accumulate it internally into some kind of like a collection. And the only way you're allowed to implement a collection is by using a primitive array. So maybe inside your log class, you want to have an array to store every fix that you may add into the log by using the add fix. And for this, you may want to look into the add entry method in your part 2 review tutorial series. You will do something very similar over there.
Can you say again? Add entry method?
Add entry. So if you go to your review part 2 and go to the refurbished store class, and then there's the add entry method. Basically, that's a programming pattern we have. The programming pattern we have been speaking about, right? So you want to make sure every time you add something to the array, you also need to update the counter properly. Maybe that's something you haven't done properly, I guess.
That's well, for the first one, I just kind of basically printed out those brackets, but it's not a correct way. I figured out.
Yeah.
The only way to play them both is
yeah. So I think one thing you can check is make sure whenever you add a fix, you really add it properly into the array. That's number 1. Okay. Number 2, when you want to print out, let's say when you say app updates that get fixes, notice that get fixes does not return like an array of log. It does not return an array of string. It only return a single string. So that means your get fixes method may have to somehow go through the array of fixes and then somehow generate this string, maybe from a loop or something. That's basically what you have to do.
That's where I'm stuck.
So maybe okay, maybe we should look at what you did during my office hour. So I think I can give you some more specific hints.
You have office hours today or?
Today, 3 p.m. Just come and then we'll talk about it.
Okay. All right,
okay. Sounds good. Good. All right, guys. Now the floor is open for any questions you might have. We got 15 more minutes if you got more questions. Okay, I'll wait for one more moment. If no, then off you go. You can do the written test today or tomorrow by 2 p.m. Just make sure you watch out for the deadline. Alrighty. Thank you so much. And then if you got more trouble, reach out to me by email or office hour. Otherwise, I'll see you next week for the Q&A. All right, you guys take care. Bye-bye.
Yes, sir.
Oh, you got a question?
Yeah, one last question. Sorry. I was just wondering if I could use math.round for lab 1. Because I know there's so many restrictions.
Yeah, actually, that should not be allowed because that one is actually using the library. You can easily do what we did to format a number back in part 1 of the review tutorial.
Part 1 of the tutorial. Okay.
Yeah.
All right. Thank you so much.
No problem. Okay. Guys, before I end the meeting, any more questions? Feel free. Okay. If no, then okay. See you later.